Hey guys, welcome back. Hope you had a great day today. We are going to talk about simplifying real nth roots. So an nth root could be a square root with an index of 2. It could be a third root with an index of 3. It could be a fourth root with an index of 4, and so on. The word real means that we are eliminating the possibility of complex solutions, or I. We're not going to deal with I. That's the implication of the word real. You can have a negative radicand under a odd root. You could have the cube root of -8, but now we will not be able to have a negative under an even root. We won't be able to do that. There will be no real solutions. And we're not going to worry about trying to simplify and find the complex ones, okay? That's the implication. So when we have even roots, that would be like a square root or a fourth root or a sixth root, you're going to follow the sign indicated by the problem. Okay, we have to think through this because sometimes when we have even roots, we can multiply two positive numbers together and get positive, and we can multiply two negative numbers together and get positive. So 64 would have two roots. Okay, so you're going to follow the lead from the question. If there is a plus or minus in front of the problem, then you're going to put a plus or minus in your answer. If the problem is asking you to state the opposite root only, then you're only going to report the opposite root or the negative root. Okay, notice that my negative is not under the radical, it's out in front. We can have that. If there is not a plus or minus, then you're just going to report the positive root. This is known as the principal root. Principal root, okay? All right, so let's think about taking a square root. We're familiar with this. So the thing behind the thing is that you're looking for numbers that can be grouped in twos. So sometimes you have a perfect square, like 36, where we can write 36 as 6 times 6. Then you have that double under the radical, and then that comes out as a single, right? So we could write this as, let's simplify the square root of 36. We could write this as 6 times 6, which we could write as 6 squared. And this undoes, and so we just get a 6, okay? Don't like that one. I got a new pen and I don't really like it, so I'm going to go back to my old one. And notice that I followed the sign in front. It was just looking for the principal root, so the principal root is all that I did. Now, not every number is a perfect square, so if you look at number 2, we have to do some prime factoring. I'm going to divide by 3, and that's going to give me 16, and then I know that 16 is a perfect square, so I'm going to take out the 4's, and then I'm going to leave my 3 under the radical, okay? So I'm removing all my my pairs of 4's, in this case, all of my pairs of the same factor, okay? On 180, I'm looking for the plus or minus, both roots, both the positive and the negative. I'm going to divide by 5, and that gives me 36, and then that's 6 and 6. So I didn't do this on number 2. I could write this as plus or minus 5 times 6 times 6. All right? I'm going to use parentheses, okay? So these 6's are a double, right? We did this before. So they come out as 1 in front, so I have plus or minus 6 root 5, okay? Now with variables, you want to group them in the same size as the index. So remember, these are all index of 2. Okay, when there is no index, it's understood to be a 2. So this is an x and an x. So that's going to come out as a single. And then I have another x and an x. What's that going to come out? Another single. So I get x squared. Okay, let me square my answers off here. Okay. And then, oh, why don't you guys try number 5 and come back and see if you got it right. All right, so I have this negative sign. I'm going to keep that out there. This is, the x's are going to simplify into 2 groups of 2. So I have an x squared here. And then I have how many groups of y's? Well, I have a y times y. That's one group. And then I have a y times y. That's a second group. And then y times y. That's a third group. And then y times y. That's a fourth group. So this is x squared y to the fourth. There's my final answer. Oh, and then I have a negative out in front. My negative out inside because it's asking me for the opposite root. Okay, so if we looked for groups of 2 with a square root, what do you think we're going to look for with a cube root? We're going to look for groups of 3. So a third root is a number that when raised to the third power equals the radicand. So I'm going to prime factor and then look for groups of 3 of the same factor. So if I do a 2 and a 2 and a 2, this is the equivalent of 2 times 2 times 2, right? So groups of 3 come out as a single because they undo each other, right? So this is going to equal 2. That's simple. But not every number is a perfect cube. So we're going to prime factor. We're going to look for numbers that have groups of 3. And then anything that doesn't have a group of 3, we're going to leave under the radical. So I'm going to prime factor 54. And when I prime factor 54, what am I going to get? I'm going to divide by 2. And then I'm going to divide by 3. And look, I have a group of 3 3s. Okay, 3 3s. So this is going to come out in front because that's the cube root of 3 cubed. So I'm going to have the opposite of 3. And then I'm going to have under the cube root symbol, I'm going to have the factor that's left over. So here is the opposite of the cube root of 54, simplified, is the opposite of 3 cube root 2. All right, we're going to do the same thing with number 3. I'm going to take 48 and I'm going to prime factor it. Now don't be alarmed about this. This is okay because we have an odd root. We're just going to have a negative in our answer. So I'm going to move my negative down. Okay. And then 48 is, what do we have here? We have 2 and 24. I'm not going to have room there. We have 2 and 24, 2 and 12, 2 and 6, 2 and 3, right? So these are a group of 3 2s, so they're going to come out in front. These are going to get multiplied together and stay underneath the radical, okay? So I know that I'm going to have a 6 underneath there. and that needs to be a cubed root. And now I have to work on my x's. I have 5 of them. So these come out as an x, all right? And these stay under. So I have an x squared there. I need to make some more room. So I had my negative, I had a 2, and I had an x. Just one of them comes out because that's a group. That means that I have to keep x squared underneath the radical. And now I'm looking for how many groups of y's. Okay? There's just one group of y's, so it comes out. And there's nothing left underneath the radical. So here's your final answer for number 3. Okay, why don't you try the video question now, and then we'll come back and we'll do number 4 together. Okay, hopefully that video question went well for you. It should have been pretty much like number 3. Number 4, we're going to group these. There's 6 x plus 2's. So I have x plus 2, and x plus 2, and x plus 2. So that's one group of them, right? So I know that I have at least one x plus 2. Now I have an x plus 2, and an x plus 2, and an x plus 2. So here's another one. So that means I have 2 of them. So the cubed root of x plus 2 to the 6th is x plus 2 squared. And then we can do the same thing for 4th roots, okay? So you're going to prime factor, and you're going to look for groups of 4 of the same factor. They come out as a single. So this is the 4th root of 2 times 2 times 2 times 2. I have 4 of them under, so this is the 4th root of 2 to the 4th, so that gives me 2. These undo each other, okay? For 162, I'm going to prime factor, and I'm going to start with 3. And I have 3 and 54. And then I have 3 and 18. And then I have 3 and 6. And I have 3 and 2. This is a group of 4 3's. So that's 3 to the 4th. So the 4th root of 3 to the 4th is just 3. The negative is from out in front. And then I have the 4th root of 2. So it's negative 3, 4th root of 2. All right, I want you to try number 3 as your video question and see how you do. All right, so 80, I'm going to divide by 5, and then I get 16, and I know that this is 2 to the 4th. Okay, so I know that I'm going to have a 2 out in front, and I know that I have to have a 5 that stays under the 4th root. Okay. Now I'm going to work on my x's. So I'm going to group them in 4's. That's 1. That's 2. That's 3. That's 4. That's a total of 16. So I know that I'm going to have x to the 4th out here. And now I'm going to look and group my y's in groups of 4. Oh, look, I don't have it. So that means all 3 of those y's have to stay under. Whoops, that should be a cube, sorry. Sorry. Okay. All right, why don't you try number 4 as your video question and see how you do. All right, I'm going to group these. This is 2x and 2x and 2x and 2x. That's a group of 4. So I know that I have at least one of them. And then I have 2x and 2x and 2x and 2x, right? That's another. So I get 2x, that whole thing squared, or 4x squared. Right? Thanks for listening. We'll work on this. We're going to do everything by expansion, and then tomorrow night we'll learn something a little bit faster. Thanks for listening.